5 seconds. Gentlemen, please start the timer. All right, hello everybody. My name is Marco Castellana. I am VP Product of the Einstein team here at Salesforce. And I'm going to do a quick introduction to artificial intelligence with some examples from Salesforce. So I'm going to try to demystify some of the terminology of artificial intelligence. Before I begin, the purpose of artificial intelligence is to make forward-looking statements. But if I make any forward-looking statements, please make your purchasing decisions based solely on present functionality. Now, Einstein is not a general-purpose artificial intelligence toolkit. Einstein is AI for CRM. It's artificial intelligence for the Salesforce platform. And that means a few things. It means that, yes, it's constrained to be within the Salesforce platform. And that means that it doesn't do everything that you can do with AI. You're not going to build a self-driving car with Einstein. That's not what it does. But if you have a bunch of data in Salesforce and you're looking to get insights from that data, Einstein is the AI for you. And there are, broadly speaking, 3 different types of things that you can do with Einstein. There's descriptive analytics. Why were my sales in California so good last quarter? Tell me why. Find me the insights. There's prediction. Tell me which customers are going to attrit in the next month. And there's prescriptive, kind of what if. Which of my territories are going to underperform this quarter if we don't assign additional resources? So those are the 3 broad kinds of things that you can do with Einstein. Now, the real reason why you all came here to Trailhead DX today, the real reason why you all flew from 4 corners of the globe is to sit here and watch me talk about Taco Bell. We're going to talk about Taco Bell. That's right. Now you're really going to regret having that conference food. All right. Now, it's pretty well known that Taco Bell has this giant menu, and they make this big menu with 6 ingredients, by and large. There's beef and cheese and lettuce and tomatoes and beans and tortillas. And with these 6 ingredients, they make this whole big menu of quesaritos and burritos and Crunchwrap Supremes, and you can tell that I'm pretty familiar with the Taco Bell menu because I like to eat there a lot. By that same token, well, I'm now going to present to you the Taco Bell theory of artificial intelligence. Einstein, and actually in general, artificial intelligence toolkits are like Taco Bell, in that there is a set of ingredients that you have, and with those ingredients, you can create all of these different menu items. So if you consider the ingredients that we have today in Einstein, the first one is a yes and no prediction. So for example, like lead scoring in Sales.Einstein is a yes and no prediction. Yes or no? Is this lead going to be a good lead for me? Or yes or no? Is this customer going to attrit or not? Yes or no? If I send you an email, will you open it or not? Now, the natural output of a question like that is going to be a probability. So when you ask yes or no, it's not going to tell you yes or no. It's going to say, this guy's got a 15% chance of opening this email. And then you can base your segmentation on that. The second ingredient is numeric predictions. How much is this account or is this opportunity going to close for? How much money are we going to make overall in this quarter? How much inventory are we going to use? How many days is it going to take you to pay your bills? Those are all examples of numeric predictions, and that's another ingredient. Now, sometimes we have single ingredient applications. So I said it earlier, lead scoring is one of those things. There's just one ingredient in there. Yes or no, is this going to be a good lead for me or not? Sometimes it's nice to just eat cheese. And sometimes we mix these ingredients together. So consider the upcoming Einstein forecasting. There's a forward-looking statement. Einstein forecasting is in pilot right now. And forecasting is at its core a mixture between 2 of these ingredients. The first one is a yes and no prediction. Yes or no, is this opportunity going to close one or not? And that comes back in probability. So let's say this opportunity has a 40% chance of closing one. And then there's a numeric prediction in there. How much money? What is the amount that this opportunity is going to close for? So let's say an opportunity is going to close for 100K, and it's predicted at 40%, then your predicted forecast for that opportunity is $40,000. You just multiply the two together. You add them all together for all of your opportunities for a quarter or for a year, and you have your predicted forecast. So that's an example of a multi-ingredient menu item, if you will. So then there's some stuff that's not exactly predictions, but classifications. And classifications can be applied to structured and unstructured data, but they're often applied to unstructured data. So one of the classifications we might make, let's say I took a picture of you all, and I fed it into Einstein Vision. It could tell me how many people are in this audience right now, how many men, how many women. Are there people in the audience right now, or is there a bunch of empty chairs? And you can apply classification also to text, to natural language. We sometimes call that natural language processing. And so there you can extract data from long-form text. And so that's powering, for example, another forward-looking statement, our upcoming chatbot, Einstein Bots capability. That's how it knows when you make an utterance in there and you say, hey, my order is late and I want to cancel. It has to decide, what am I doing with this text that this person just sent me? Are they asking about shipping? Are they asking about cancellation? Are they asking about billing? What are they asking about? It has to pull that out in a structured way in order to know how to respond. So what is AI? Simply put, AI is a system that learns from your data. That's all. And sometimes when you look at it, and in fact, I'm going to show you a demo in a minute, so this is not going to be all slides. But when you look at it, it might look sometimes like it's rules, like somebody's in there. You know, if you think about lead scoring with some systems, other systems that are not Salesforce, you know, if you're doing lead scoring, you put in these rules. Hey, if it's in Kentucky, I'm going to add 1. If it's in West Virginia, I'm going to subtract 1. This doesn't work that way. This learns from your data. So if your leads just perform better in Kentucky, it will bump up Kentucky. And if they perform less well in West Virginia, it'll bump down West Virginia. That's the concept. The whole idea is that rules, although they're a key part of this, rules are never really up to date. Going back to our ingredients, we have a couple more. Recommendations. People who bought these shoes also bought these socks. You just bought these shoes. Maybe you should think about buying these socks. We have recommendation engines in both Commerce Cloud and Marketing Cloud for products and for content, respectively. And the last thing, and I kind of just alluded to it a minute ago, the last ingredient that we have in Einstein, as it is right now anyway, is not exactly an AI ingredient. It's the tortilla. It's rules. Rules and workflow are required to make any AI system work. You know, you can be making all of these predictions. Let's say that you have 2 million customers and you build an attrition prediction and 50,000 of them are predicted to attrit in the next month. What are you going to do about that? How are you going to handle 50,000 of these things? There is no human on earth that can go through 50,000 of these in a month. You need to set up workflows and rules. That is the Salesforce platform. That's the whole point. And so Einstein is part of the Salesforce platform, and the workflow and rules that we have are Process Builder and Workflow Rules and Apex and Assignment Rules and all those things that you use every day in Salesforce. That's the tortilla, because you think about it, put all these ingredients with no tortilla, just it goes through your fingers and makes a mess. All right, so how does this learn? How does this learn? There are actually two main methods by which this learns. The first one is statistical machine learning. So statistical machine learning, which is actually quite hard to say, is a big, giant correlation engine. It's finding the correlations between your data and the outcome you're looking for. So I said lead scoring is, it's good to use lead scoring as an example because it's easy and relatively simple. So your outcome is, you know, if you look at your history of data, some of your leads converted, most of them did not. So we're going to find the correlations between the things we knew about the leads back then and whether they converted or not later on. Your leads came from West Virginia, they didn't convert. Your leads came from Kentucky, they did, they tended to. Leads came from an industry event like this, they tend to convert. Leads that you buy from whatever aggregator, usually not. So we will find those correlations in the data and then put them all together, weight them against each other, and create an equation out of them. And that equation ultimately is what spits out the scores, the predictions that you see. And we'll see that in a demo in just a moment. The other side of the coin here is deep learning. deep learning learns more like your brain. So, if we look at statistical learning is great on structured data because it is a correlation engine. It's the kind of thing that you could conceivably do manually in Microsoft Excel or something if you wanted to. Although imagine if you have thousands and thousands of fields, that's not so tenable. That's why we use machines for this, and that's why we call it machine learning. Deep learning learns like your brain, like I said, and so it's really good at finding patterns in unstructured data. So, what's amazing is the guy who made this deck, James Harrison, the late, great James Harrison, is he here? No, he's late. He's still alive, but he's delayed. In any case, now he searched me on Google, and he found this picture of me. Now, Google uses deep learning also to do its image searches and stuff like that. And so my former mustache that I shaved off last night still shows up. It's very robust in the presence of noisy data. But so deep learning is great, and that's what we use to power Einstein Vision and to power Einstein language services. It does have a downside, though, which is that it doesn't always explain itself. Statistical will always tell you exactly why it's making a prediction. Deep learning doesn't. In the same way, why was I dreaming about driving in the snow last night? I have no idea. That's your brain. All right, so with my remaining 8 minutes, we are going to explore a couple of common terms in AI, but we're going to do it right in an org. So we're going to look at it in Salesforce and see what they translate to in the real world. So we already kind of talked about artificial intelligence and machine learning and deep learning and natural language processing. So let's put those aside for the minute, and let's focus on the stuff on the right here. Algorithm and model and features and classifications and predictions, and there's a couple more terms I have on my little piece of paper over here that we'll walk through as well. So let's de-slide ourselves. All right. So here is a prediction that I made with the upcoming Einstein Prediction Builder. Einstein Prediction Builder, for those of you who haven't seen it already, is part of the My Einstein platform. It's the ability for you to build your own custom predictions in Salesforce that's in pilot right now. Another forward-looking statement. And here I have an attrition model. So I'm playing the part of a bank, and I want to know who is going to attrit from my bank. Einstein Prediction Builder, at least right now, is only using the statistical type of learning. Right now. It won't always be that way, but for now, that's what it's doing. And so, like I said, statistical methods are generating an equation. And that equation can easily be sort of reverse engineered to say, OK, well, why are you only predicting that he's going to trade at 6%? Well, because he's been with us for a while, and he's in a state that we're good with, and whatever, his money outflows are not so bad, whatever. So these things up here in AI speak are... Sorry, folks. Technical difficulty. Crossed. OK. We're back. We're back. Hopefully you can hear me. All right. These things are what are confusingly known as features. In AI speak, you have your features. Those are the things that help you predict the outcome that you're trying to predict. In this case, the outcome I'm trying to predict is yes or no, is this guy going to attrit or not? And that thing, the outcome that I'm trying to predict, is even more confusingly called the label. Now, incidentally, you will not ever see these terms in any Einstein thing, except maybe Einstein Discovery, which is a little bit more advanced. You'll not see these things in Einstein Prediction Builder or in lead scoring. These words, algorithms and features and labels, derived features, aggregates, all that stuff, that's all the stuff that Einstein is doing for you. So you don't have to do these things. But in case you see these things come up, now you know that's a feature. Now, let's consider also, I mentioned it just a second ago, a derived feature. What is a derived feature? Really, a derived feature, so a derived feature is, so here we have our contact record. And your contact record doesn't store all the data about your contact. You're going to have child records and parent records. The parent record might be an account. Child records, in this case, would be money transactions. It could be emails. It could be whatever. A derived feature is a piece of data that you're grabbing from a related data set. So here, money outflows, last 30 days. That's a derived feature. It's a roll-up summary field that's pulling from my, my transactions record, which is down here somewhere. The money transfers, there it is. And so that can help you predict, right? So these things can help you make the kind of prediction you want. Now, a lot of times what we found is that, at least in the pilot process for Einstein Prediction Builder, we found that in a lot of cases, the objects that you're predicting on or about are the ones that you're heavily reporting on. You know, for example, we have a few customers that are using Einstein Prediction Builder, so they're doing their invoicing out of Salesforce. And they want to predict, are you going to pay your bill on time or not? Again, another yes and no question. Notice a pattern there. And we find that in most cases, when they have whatever their invoice object in Salesforce is called, it's a custom object, they usually have a bunch of roll-up summary fields and formula fields in there that are just naturally deriving data from the objects around it. And that helps Einstein Prediction Builder make its predictions. So those are all good. Now, let's walk into Einstein Prediction Builder to get into another couple of things. So I already have a builder model in here. I'm going to make a new one. Let's make a new turned to model over here. All right. And I'm going to do the same thing I had earlier on the contact object. Now with Einstein Builder, just about every standard object and certainly every custom object is available. And I'm predicting whether, so what I'm really looking at is, I'm looking at my past sample of data. And I'm saying, I have a label on here, a label, called attrited. So this is my outcome that I'm trying to predict. I'm looking back and saying, I want to know who has attrited in the past. And then I'm going to save it to the attrition risk field. OK, so here are all, I said it earlier, all of the features that are available to me are just the fields on the contact record. And I can turn some off if I want to. For example, if I really was a bank and I had gender or something on here, I'd have to take that out because regulations say you can't use gender in your model. But we encourage you to leave them all in as much as you can, because the whole idea is to let the machine figure out what matters and what doesn't, what correlates and what doesn't. And then, segmentation. So segmentation is interesting. So I can say, hey, I just want to build this model for my California customers. And I'm going to do a different one for New York or something. And so I could segment my set. I could say, OK, this one's for New York, this one's for California. These are two different things, two different filters, two different things. And then you have this notion of training versus scoring. So there's two more terms. Training is the set that it learns on. This would be your historical set of data for which some of your customers have attrited, some of them have not. And scoring would be the set of people that you want to make this prediction about. So like, going back to the customer I was talking about with the invoices, their training set were all their closed invoices. They had a whole bunch of invoices they sent in the past. And they considered them closed either if the person paid or if they just didn't pay and they just gave up. They're just like, forget it. This guy's never going to pay. Either way, that's a closed invoice. And that's what we want to learn from. And our scoring set was open invoices, the ones that are currently out there, because that's where we want to make the prediction. And that's it. Now, what you don't see in these screens is any notion of, well, not even the word model. You don't even see the word model. What is a model? A model in this concept is basically that equation. It's that equation that comes up with the score that you saw earlier over here. What is an algorithm? An algorithm is the method by which the computer arrives at that equation. And actually, what Einstein is really doing right now, as a matter of fact, since I pressed that button, is it's going to run a whole bunch of different types of algorithms. There are all kinds of algorithms. I mean, hundreds, thousands of them, And so it's going to run a whole bunch of these algorithms on it. And it uses a number of different statistical measures to come up with which one of these algorithms is the best. And that's the one that it applies to ultimately arrive at this score, which is then affected by the data. So here, this algorithm found that external accounts is something that matters to this particular prediction for this particular customer. So if I add an external account here, for example, and we reload the page, and the demo gods are kind to me, which they are, then you see that our likelihood of attrition has now changed as a result of the fact that I changed a correlated variable. Actually, what I really changed was a sub-object, which updated a roll-up summary field, which was a correlated variable, which changed the score. And that is the 20-minute introduction to how artificial intelligence works. Thank you very much. I'm not much of a dancer.